something we can definitely be sure of when it comes to numbers. There are too many of them, infinite to be accurate. And interestingly, the same is true for complex numbers. If you remember, we learned some quick go-to laws that apply to all the real numbers and that made our lives easier. Now, good news for you, we have some real helpful laws for complex numbers as well. They are called theorems. And to understand them, we will be using different complex numbers belonging to set C. Now, on to our very first theorem. That's a lot of letters and bars. But hey, nothing to worry about. One step at a time. First, let's take complex number z. Its negative counterpart is negative z, which means its real and imaginary components are negative as well. Then the conjugate of z is z bar, which puts a minus sign in front of the imaginary part only. And finally, we have the negative of the conjugate. Can you guess what it looks like? Great! Now, the theorem says that the modulus of all the four terms is equal. Let's find out by calculating the modulus for each, starting with z. Note that value. Then, calculate negative z. Notice how the minus signs go away because of the squares? So, we will end up with the same value as before. And guess what? It's the same story with the conjugate, as well as with the negative of the conjugate. Hence, they are all equal to each other, just as the theorem said. God, I love these helpful theorems. Now, on to the next one. Double bars? That just means the conjugate of the conjugate. Let's begin with z and get its conjugate. Now, how do you take another conjugate of this z bar? Well, you simply multiply the imaginary part by the minus 1 again. And there you have it. It's equal to our original complex number. On to the theorem 3, my friends. We have z and its conjugate ready. All we need to do is multiply them together. You may already know where this is going. The product of conjugates is always a real number. So, we will end up with this. That's it for the left-hand side. But it kind of looks familiar. No? You guessed it right. It's just the modulus of z but squared. Apply the square to both sides of z and boom! Our theorem number 3 has hence been proved. Now, how about number 4? It says either you find the conjugate first and then sum up the complex numbers, or you find the conjugate after summing up the numbers. The result will be the same. By now you must be getting a hang of this. So the notation hopefully won't seem so scary. Now firstly, let's assume two complex numbers z1 and z2. Then let's get their sums. We will group the real and imaginary components together, making it easier to multiply the imaginary part with the minus 1 for the conjugate. Take this result and now simply rearrange the numbers from it. Do you notice something? Yes, that's right. We just ended up proving the theorem. How about solving a relevant example on the go? It asks to show that finding conjugate before multiplying the given complex numbers yields same result as of finding conjugate after multiplication. So, let z1 and z2 be the same complex numbers again and pick the left hand side. Substitute the values and multiply using the formula. After that, take the conjugate of the product and hold the result. Moving on to the right hand side, it requires us to find the conjugate of z1 and z2 first and their product afterwards. The result is the same as before. And that's our proof. Good practice, isn't it? But we have some more theorems left beside these 4, which we are sure you must be excited to find out. So, head on to our next video and we will see you there.